Hello, everyone. Thanks for joining us. Welcome to this current session of the Earth Engine virtual meetup. We're really happy to have you here. I'm Sabrina Zito, and I'm a geospatial consultant based near Munich in Germany. And I would like to also invite the co-host for this season.
Hello, everyone. Thanks for joining us. Welcome to this current session of the Earth
TC
Engine
to introduce himself.
We're really happy to have you here.
Hello, everyone. I'm TC. I'm a PhD candidate at Yale. Sabrina, I think your YouTube is on. And Sabrina, do you want to take it over?
Sure. So thanks again for the reminder. I just turned off the YouTube. I was just checking it. So we are live on YouTube right now. And if you head on to bit.ly/evm-YouTube, you will get a recording of the past session as well as other sessions. And we will be uploading the presentations as well to YouTube. So people who can't make it or want to watch this again later can do so. And we have had bi-weekly talks this fall and winter all the way until the end of December. So this is our second last session for the year, and you'll get more information about our next session at the end of today. So we're really excited today to have Abena Asare Ansah, who is a remote sensing and GIS analyst at CERSGIS, based in Accra, Ghana, to be with us, to be our guest today. She'll be talking about monitoring aerosol concentrations of the Sahara Desert using Google Earth Engine. So that will consist of the first part of our session, followed by Q&A. And then the second part of our talk today will be looking at some troubleshooting tips and tricks. So you'll get a chance to share your own questions and topics that you're working on. And we as a community can also help you answer some of these questions. So later on, we will be having the Q&A on slido.com. That's where you'll be able to post your questions. So if you open a tab on your computer and go to slido.com, and then you can type in the event code, which is #EEVM, you'll be able to post your questions live. And during the Q&A, that's what we'll be using. So we'll come back to this later, but right now I want to hand the mic over to Abena to get started with her presentation. So I will stop the screen sharing now, and then Abena can take over.
Hey, hello everyone. So like Sabrina said, I am Abena Asare Ansah, and I work with the Center for Remote Sensing and Geographic Information Services as a remote sensing and GIS analyst. I'm based in Accra, Ghana. And for today's session, I'll be talking about how to monitor the aerosol concentrations using the Google Earth Engine. So I'm just going to share my screen and then I'll start talking about what I have today. Okay. All right, so I hope you can all see my screen. So these are just some few pictures I had online about the Sahara Desert, which is in the northern part of Africa. In the first image, we can see some sand, and then in the second image, you can see some camels, and in the third image too, we can see the Sahara Desert during nighttime. And I think these are very beautiful places within the Sahara Desert. So like I said earlier, the Sahara Desert comprises of countries such as Mauritania, Mali, Niger, Chad, Sudan, Algeria, Libya, and Egypt. And according to research, the Sahara Desert has an area of about 9,200,000 square kilometers, and that covers about 31% of Africa. And research also shows that the Sahara Desert is the largest hot desert in the world, and it's also the third largest desert in the world. And another thing to have come across is that the sky in around the Sahara Desert is usually clear. and the sunshine duration is extremely high. From the few articles I read, the temperature there can go as high as 47 degrees. So the desert area is really, really hot. Okay, so what are the components of the Sahara Desert? So what makes up the Sahara Desert? The Sahara Desert is mostly made up of sand. You find sand almost everywhere. There's rocky plateaus. They also have salt pans, sand dunes, some mountains, and some dry valleys. And I was actually surprised a little when I came across the fact that the desert has over 20 lakes, and most of them are salt water. But Lake Chad is the only one that has fresh water in the desert. And I think that's a very interesting fact to know. But despite the harsh conditions of the desert, there are several plant and animal species within this area. And there are about 500 species of plants, 70 species of mammals, 90 avian species, and about 100 reptilian species across the Sahara Desert. And then there are also several species of spiders, scorpions, and other arthropods, according to World Wildlife Fund. Now, there's something, a blanket around or within the Sahara Desert area, which is popularly known as the Saharan air layer, or also known as the dust plume. Okay. Now, this dust plume is a blanket of dust that is able to travel from Africa's deserts across the Atlantic Ocean. And this is part of a natural phenomenon. And it also helps to improve the Earth's nutrient cycle. And this form of travel or this kind of dust travel happens between late spring and early autumn. And this mechanism actually involves high velocity winds that carries these tiny particles of dust from the Earth's surface through long distances. And it has a great potential of nourishing plants and ocean life. So despite the fact that the Sahara Desert dust is dusty and maybe it can affect health of human beings, it also has a very good part in the sense that it's able to support plant and ocean life. And another good thing about this Saharan air layer or this dust plume is that it's able to suppress tropical cyclone or hurricane formation and intensification. So throwing more light on that, the SAL is able to indirectly impact the sea surface temperatures. So we know that for storms or hurricanes to form, we will need cloud formation. But this SAL or this Saharan air layer is able to reduce the amount of cloud that forms around the Atlantic Ocean surface. And then it's able to suppress or reduce the formation or development of tropical cyclones. So in June 2020 this year, there was actually a big blow or something great that happened across Africa, towards the Caribbean and the United States. And that was the Godzilla. Okay, I know maybe a couple of us heard about it. This Godzilla was a bigger portion or a bigger form of the Saharan air layer or the dust plumes that travels across Africa to the US or across the Atlantic Ocean. But what was extreme about this type of dust plume was that it traveled over 5,000 miles compared to what used to happen in the previous years. And information from National Oceanic and Atmospheric Administration states that this Godzilla plume or this dust plume was about 60 to 70% larger than the average plume travel in the past. And then also data from Aerosol satellites indicated that the dust was about 3 to 6 kilometers above the ground, which is about 3,000 to 6,000 meters. And I think that is very, very huge a number. And this year's plume also appeared to be the thickest and the densest to cross Atlantic Ocean towards the Caribbean and the Americas since the start of satellite monitoring in 1979. Now, currently, the cause of this Godzilla or this huge dust plume remains unclear or is quite uncertain. And a couple of articles I read give out some possible hypotheses of whether the cause is a meteorological anomaly or is an effect of extra earth warming degeneration into extreme convectional currents. So those of us who are interested in topics related to Sahara air layers and dust plumes can look further into this hypothesis and see what they can come out with. So I'm just going to show a short animation on the extent of the Godzilla across the Atlantic Ocean. So this is an animation that shows the extent of the Godzilla or the Saharan air layer, which traveled across or from the Sahara Desert towards the western part of the desert. That's towards the Caribbean and then the United States. And then the lower portion of this window shows the dates or the period of the capture, which was from 1st of June to I think 26th of June. So you can see that daily we had a lot of changes over the Earth's surface. It traveled about 5,000 miles across this area. So one satellite mission or one satellite that was able to capture this phenomenal activity is the Sentinel-5P, which is also known as the Copernicus Sentinel-5 precursor mission. And Sentinel-5P is basically dedicated to monitor our atmosphere. So it's able to pick data on air quality, ozone, and UV radiations. And then it's also able to pick data on climate monitoring and then forecasting. So those of us who are interested in this this Sentinel-5P satellite mission can click on this link and then have more information on that. Now, also available on this Sentinel-5P mission is a product known as the UV aerosol index. And this product is a qualitative index that indicates the presence of elevated layers of aerosols. Okay, so this product has captured or captures information about aerosol concentration on a global scale, okay? So this kind of information is available. And the main types of aerosol it captures are desert dust, biomass burning, and volcanic ash plumes. So if you're interested in finding some more information on volcanic ash plumes or biomass burning, you could also have a look at this data available on Google Earth Engine. Okay, so like I mentioned earlier, the UVAI or the UV aerosol index, which is also known as the absorbing aerosol index, is available on Google Earth Engine. And the dates available are from July 2018 to present. And this data set has a spatial resolution of 0.01 arc degrees, which is about 1.11 kilometers. So if you're interested in looking at something related to aerosol for your area of interest, you can just check it out. And one thing I've realized from this data set is that anytime you inspect the data set and then the AI or the index is positive, it gives us an indication that there's enough or there's a lot of aerosol concentration like dust or smoke within that particular space. So if it's negative, then it means that there's a lower concentration of aerosol for that particular area. And hence it is very useful for tracking the evolution of aerosol plumes from dust outbreaks, volcanic ash, and biomass burning. So again, if you want to have access to this absorbing aerosol index available on Google Earth Engine, you can click on the link in the slide and then you have access to that information. Yes, so I know a couple of us are Google Earth Engine users, but for those of us who do not really know much about Google Earth Engine, it's a planetary scale platform for science, data, and analysis. And Google Earth Engine has a lot of data sets on climate, on water, on surface temperature, on so many things. So if you do not have access to Google Earth Engine or you are not a user yet, you can just click on the link in red and just sign up to have an account on Google Earth Engine. And I promise you that I'm going to really have a good time there. So for the purpose of my work, which is monitoring aerosol concentrations in the Sahara Desert, I used Google Earth Engine, and it's actually something simple I did on Google Earth Engine. So what I did was that I was interested in the June 2020 images, okay? And then I didn't want to have a lot of images or daily images from June 1st to June 30th. So I decided to create average composites for my area of interest and then for the time period June. So from this image, I'm sure we can see, what I did was that I called in the aerosol data set, okay, which is the EE.image collection. And then for each of the dates I was interested in, I used a filter to filter out the dates I'm interested in. So I just decided to create a list of my dates. So I used E.filter for June 1st to June 3rd, June 4th to 6th, 7th to 9th, 10th to 12th, 13th to 15th, 16th to 18th, 19th to 21st, 22nd to 24th, 25th to 27th. And then I also did it for 28th to 30th of June. And then my interest or the band I was interested in was the absorbing aerosol index. So I wrote that code to select this particular band of interest. And then I mapped it over the function to clip to my area of interest. My area of interest was Africa. So I ran the clip to clip out this global data set over my area of interest. And once I was done, I created a mean. I created a mean for my dates of interest. So when I select, let's say, June 28th to 30th, June 28th to 30th has 3 days. So I just create a mean out of this time period, and then I can just have one image that shows the aerosol concentration over my area of interest. Then I gave it a visualization parameter, and then I visualize my image on Google Earth Engine. Then I exported all these images into my assets because I needed to write another code to pull out all these images and create a GIF out of what I was doing. So I think I can just click on the link and then we can have a look at the codes. Okay, so this is the code that is showing the aerosol, absorbing aerosol index product for 1st June to 3rd of June. It's actually the mean, okay? So that is just that for 1st to 3rd of June, 2020. Then I can just uncheck these dates and then check another date, run it, and then have a look at the products for 10th to 12th of June. All right, so this product is also telling us that there's actually something going on around the Sahara Desert, okay? So the areas in cyan and light tan is actually the high aerosol concentration areas that we can see. So that was what I was actually interested in. So I had a look at all this. For all my 10 images I was interested in. So I want to have a look at the image for 19th to 21st of June. And that is the output that shows the image from 19th to 21st of June 2020. And you can see that as the days go by, the concentration of aerosol is moving towards the western part of the Sahara Desert. So just by looking at this data, you can have an idea of what's actually going on across the Sahara Desert. So I move back to the presentation. Okay, so these are some composites, average composites of the product I just showed you. So from 1st to 3rd June, that's the composite I had. From 13th to 15th June, that's the composite I had. The violet areas have less or no aerosol concentration at all. But across the Sahara Desert, those areas are the cyan and the light tan areas. So those areas have high aerosol concentration. Then from 28th to 30th June, you can see that the movement has actually shifted to the western part of the Sahara Desert. And I'm sure if I had captured images around or over the Atlantic Ocean, would have seen the concentration of aerosol there. And then I decided to take one for 4th to 6th June 2020. And then I realized that there's virtually not much going on around the Sahara Desert currently. And this is so because around this time, there isn't so much SAL across this area of interest. Like I stated earlier in the slides, this SAL is predominant or is very much during late spring to early autumn. So this is just a confirmation of that. Okay, so once I got all my images ready, I decided to put it into a GIF code and run it to see how this can tell a story over Africa. So I'll also load that code and then we'll have a look at it. So for this particular code, I imported my area of interest, which is Africa. And then I set a geometry or a polygon. So that will define the boundary or the area of interest. And then I also give it some visualization parameters. I set the minimum, maximum values. And then I give it a palette. Then I called the aerosol index band. Okay. And then another thing I did was that I had to also load all my images I was interested in. So I loaded all 10 images from 1st June to 30th of June. I loaded all these images because that was what I wanted to use for my GIF. Then afterwards, I created a rectangle and then I created an arbitrary constant image. So I assigned an EE.image to my images I've already called into the code. Then I created a collection of all these images. So like I put all these images in a briefcase and I arrange it according to how I want it to be displayed in the GIF. And then I assigned a color palette to it. And then I also assigned some visualization parameters to the rectangle or to the viewer that contains my image. And then this was a small or this very small code to create the GIF for my analysis. So let me just pull this up and just show you what I had. So yeah, that's the area of interest. And I displayed the first image, which is the average from 1st to 3rd of June. That's what we see here. So the white areas we see in this image are the aerosol concentrations for that particular time period. And the GIF, which is rolling in the right corner, shows the changes from the 1st to the 30th of June 2020. So by just sitting at home and just playing with these codes, you have a fair idea of the extent or the direction of the aerosol concentration across the Sahara Desert. So I'll move back to my presentation. So just like I have showed you, this is the product I generated from Google Earth Engine that shows the extent or the direction of the Sahara air layer or the dust plume from June 1st to 30th of June. Okay, so what are some of the uses of this absorbing aerosol information or index? So from this analysis or from this product I generated, it can help give advice to the aviation sector on air routes. So assuming you are flying over the desert area at a lower altitude, this product, this absorbing aerosol index products can give you a fair idea of areas that has a lot of dust plume concentration or aerosol concentration. And once there's a lot of aerosol concentration in the atmosphere, there's less visibility. So it's advisable not to fly within that range, else you might involve yourself in an accident or something else might happen to you. So it gives or it helps advise aviation on their air routes. Another use of this product is that it can monitor the direction and extent of dust plumes and predict its effect on human activities. So once you know the direction and extent of the dust plumes, it gives you an idea of areas to go to and areas not to go to within a particular time period. And you also know that once this dust moves across a particular area, it carries dust particles, and these dust particles also contains irritants that can affect or stir up certain health or respiratory diseases in the body. So once you know that you have such a health
Hello, Abena, I don't think I can hear you. I don't know about others.
I think Abena might have temporarily lost connection. So let's give her a bit of time to reconnect. And in the meantime, if you have any questions you can already think of, feel free to go to our Slido, which is on slido.com, and put in hashtag EEVM to add your questions. And then when Abena comes back, I think we'll be able to have her finish the presentation and then also share your questions. So in the meantime, yeah, I think Abena is back right now, so I will let her share the screen again. In the meantime, feel free to introduce yourself in the chat. It'll be great to see who's in the room today. And also, if you're on Twitter, please share your Twitter handle so we can stay in touch. So I'll hand the mic back to Abena.
Thank you, Sabrina. Sorry, I had a problem with my internet. So like I was saying, one use of this aerosol index products is that it also gives you an idea of marine health hypothesis. So it gives you information on marine health hypothesis, considering the transport of pathogens from the Sahara, which can also affect coral reef development and other fish species. So once you have this idea or this information on the absorbing aerosol index, you are able to do further analysis or further studies on coral reef development or other fish species, you're able to have an idea of the kind of impact aerosol index is having on soil or iron or phosphorus concentration. And I think that's a very useful information for further studies. So these are a few links or articles I read so that I could get some information to share with all of us. So in your free time, you can go through all these slides so that you can have a wider understanding of AI and then the dust plumes. So thank you very much.
Thank you so much, Abena. This was a really great presentation, and you clearly are able to communicate science very well and break down complex weather phenomena into words that many of us can understand and feel that this is an approachable topic, even though we're not experts. So thank you so much again for taking the time for this presentation.
Thank you too.
And now I'm going to switch over back to our link here to the Q&A. So if you have some questions, please head on down to slido.com and type in the event code #EEVM, and that will take you to this page here. So I'm going to exit the presentation here and head over to Slido. Great, so we have one comment so far, thank you. Somebody says, beautiful application. I didn't know about UI.thumbnail. So thanks for sharing that with us, Abena. And then somebody asked, does AI also have data over the ocean?
Does AI have data over the ocean? Yeah, I think there's Sentinel-3 that has data over the ocean. So you can also look at Sentinel-3, which is available on Google Earth Engine. And then you have information about the ocean.
All right, so if you have questions, feel free to post them on Slido and we will answer them. And somebody asked, thank you for the great presentation, Abena. I was wondering what your next steps are for this work. It's interesting stuff.
My next steps. I want to dive deeper into the various hypotheses that was raised as I was researching on this topic. So I want to look at the effect of AI on phytoplankton or on global warming. I think it would be interesting to look into those areas. And I'm open for discussions, collaborations, ideas. Yeah, I'm very open for such things too.
That's awesome. And I guess a question for me, I really like your choice of the color palette for your GIF. I feel like the different colors you chose were really effective at highlighting areas where there were lower concentrations, but also where there was higher concentrations. And you could really see the shape of the areas with high concentrations of aerosols. So how did you pick this color palette? Do you have any tips for people who want to make their own GIFs?
Yeah, I think I just checked these colors on hex colors. I just searched for these colors on hex colors and they looked very nice for me. So I decided to just use this. So anytime I want to look at colors or look for some things related to colors, I just go to hex colors. I search for it online and then I just settle on the colors, depending on what theme I'm working on.
Yeah, that's excellent. So are there any more questions? Feel free to post it on Slido. And we'll wait a few more minutes for people to formulate their questions. Okay, it seems pretty quiet. Maybe people have asked all the questions that they have. So Abena, how can we stay in touch with you on Twitter? What is your Twitter handle?
Okay, my Twitter handle is Miss Pixels. I'll share it in the chat. And then anyone who wants to follow can also get in touch with me. I've also shared my email address. So anyone who wants to get in touch can also send them an email as well. So let me quickly share my Twitter handle.
Thank you, Abena.
Thank you too.
All right, we have one more question. Can you get long-term trends from this data set? So I remember you said in your presentation, Abena, that Google Earth Engine has this data set from July 2018 for the Sentinel-5P.
Yes. Yeah.
So the long-term trends will be limited to this time frame, right? For Earth Engine.
Yes.
Yeah. So I know like they have the Modus 1 kilometer aerosol optical duct product now on Earth Engine, and I think that's available from 2001. But I don't think it's the same thing. It's total aerosols along the whole column. But for like understanding like the effect of total aerosols, that's probably an option for long-term trends.
Okay, thanks for that. I've actually not explored that data set, so I'll also look into that. Thank you very much.
Thank you, Abena. And I think another question that people might ask will also be if they can get access to your slides, because you showed some really good links that people might want to try out the code that you showed. So if you could also share maybe a link to the slides later on, that will also be interesting for a lot of people.
All right, sure, I'll do that. I'll share the slides.
All right, thank you. So now we have some time for troubleshooting tips and tricks. We have about 20 minutes left. So I encourage anybody who has a question about something that they're working on, feel free to paste your question either on Slido if you're watching from YouTube, or if you're in the room, you can paste your question in chat and we will also try to answer it. So if you have any tips or tricks or questions, please feel free to share them and we'll try to answer them as a community. So once again, thank you to Abena, and we look forward to seeing more of your good work in the future. Thanks again for joining us.
Thank you.
All right, so as we wait for people to formulate their questions, I'm going to share with you a few updates about what's going to be happening in the next session. So 23rd of December, which is our final Earth Engine virtual meetup of the year, we have special guest Sophia Armida, who will be sharing with us on a talk titled An Earth Engine Module for Calculating Land Surface Temperature Using Landsat Data. TC, do you have any other updates relating to this talk that you'd like to share?
I mean, I actually came across this data set because she published a paper in, I think, remote sensing. And it was a huge deal for at least me because I have looked into a lot of these algorithms and they work fine for like NV, but there's not a good, I guess, like centralized list of the different ways you can calculate LST and the assumptions. So I reached out to her and she agreed to give this talk. And I have been actually using her module quite a bit and it's very nice.
Oh, that's really exciting. Yeah, thanks for inviting her. And I guess because this will be the last session as well on the 23rd of December, I would also like to say a big thank you to UTC for being a co-host on the session, on the season. And it's been great having these bi-weekly talks. So thank you again for all the time you put into making this possible.
I mean, it's been great, and you were the one who kind of started this, and that's a huge. There was like a whole lot of effort in that.
Yeah, and I hope we get to collaborate again in the future, wherever you might be.
Yep.
Yeah, so in the first month of 2021, we won't have a meetup. There'll be a break in January. But please put the 10th of February on your calendar, because this will be our first meetup of the new year. And we'll be really excited to announce our guest speakers in the future. But most of all, if you would like to be featured as a guest speaker, please write to me. You can also message me on Twitter, and we would love to feature you and your work. So we're open to anybody in the community who is a user of Earth Engine to share what they're working on. So we would love to see you as well as a speaker on the Earth Engine virtual meetup. All right, so I'm gonna head back to our Slido to just see if we have any questions so far. Okay, so we have a question here from Fiona. She has a question about how GEE handles projections. She read the doc, but still is confused. And it says avoid use of reprojection except when necessary. But what is necessary? Like when would it be applicable, right, to use reprojection? So does anyone have an answer to that? How do you all use reprojections, if any? Feel free to, again, answer in the chat or post an answer on the Slido. Basically, from my experience using projections, you have to specify a projection when you say want to export an image or you want to do a certain calculation. And this will be the projection that Earth Engine uses to do the calculation or export your image. So yeah.
I have used reprojection a bit when I'm exporting in a particular projection, when I want to do pixel-wise comparison with a data set I have outside GE. So sometimes, like for instance, model results from like climate models, they have their own grid structure sometimes, which are not easy to kind of convert to geotiffs. So sometimes I find it easier to download the data from Earth Engine in a particular projection and then compare it on a different platform.
Okay, Fiona, I hope that helps a little bit. If not, feel free to post a follow-up question. And then another question from somebody is, with UI.thumbnail, is there a way to include text or a slider that changes with the frames to show, for example, the time period or year of each image / frame? I think, if I'm not wrong, I think I've seen this posted on GMap. If you use the Python library GMap to make GIFs, I think it's possible to include some text or a slider. And I think earlier on when Justin Bratton shared his code for making these thumbnails, you had to then externally add the text to go with each change in image. But then now I think there's a way to do it in Earth Engine, right?
Yeah, I've not tried it actually in Earth Engine, but I think there's a way to go about that.
Yeah, I think I saw somewhere on Twitter that there was some way to do it, and somebody shared some code.
Oh, okay.
So I think yeah, I would search online to try and find that code example again.
Okay.
Yeah. Okay, so Fiona asks if I merge images with add bands, do they need to be the same projection? I think the answer is no. You can add bands with different projections into the same EE.image. Is my experience. I've definitely done that with even bands that are different resolution as well. TC,
Yeah, I think it rescales and reprojects on the fly when it adds those bands.
Mm-hmm. All right. So I don't see any other new questions popping up. Thank you to everybody who asked questions. Thank you, Fiona, and thank you all those who also added your comments on Slido. We would love to continue to hold these meetups and would be glad to make this as useful as possible for everyone in the community. So I'd like to encourage everybody, if you have some ideas for how we can make this even better, please feel free to write to me on Twitter or post a comment on the YouTube channel, and we will continue to support this into next year. So thank you all once again for making the time to join us. And thanks again to Abena for your presentation. And with that, I will say that our session has come to an end, and we'll see you on the 23rd of December for our final session of 2020.
Right.
All right, so thank you, everybody. Please, again, feel free to post your Twitter handle in the chat, and we can all try to stay in touch online after our meetup today.
Thank you.
All right, thanks, everybody.
Thanks, everyone.
Bye.
Bye.